Algebra 1. All right, guys, we are in the very last section of Chapter 11, Rational Equations. All right, you guys have been working hard. Listen, some of you guys, you really upped your game when it came to asking questions, taking notes. That's awesome. But listen, everybody, that effort, let's keep that effort going up, okay? I know this is not an easy chapter. I know the concepts are difficult. Some of these problems take quite a bit of time, effort. There's lots of details. And if you are willing to put in the time, and by that I mean you're watching the videos, you are taking detailed notes over everything in these videos, you're coming to class prepared with your homework, you are asking questions in class, and you can think of one more thing that will help you understand math better. If you are doing all these things, I promise you, you will see big improvements. All right, not only in the obvious thing, your grade, but just in your overall knowledge of the subject and how much better prepared you will be for next year. Do those things. All right, so let's finish this out strong here. So you've been solving problems with addition and subtraction. That was in prior sections. Multiplication, division, also in prior sections. We're still using polynomials, of course, and we still have fractions, meaning common denominators are really important. And common denominators aren't just as simple as saying it's a number. It's an expression. It's like x plus 2 combined with an x plus 5. That weird type of a thing could be a common denominator, putting those together. All right, so we may have one more problem slightly similar to that. And then you will be using a method that you've done before in the past, cross multiplication. All right, cross products. That is something that you guys have done, cross multiplication. And if a problem is set up like this, so let's take a look, where you have one fraction, then the equal sign, and one fraction. Notice those are the qualifications. One fraction, then an equal sign, and one fraction. If that is how it's set up, so that meets these parameters, then you will use cross multiplication. Okay, so that would mean 6 and 2. That is what gives us the 12 right here. Then you have cross multiplication this way, but notice you have a whole expression here, x plus 4. This x needs to be multiplied into this expression, meaning x multiplied by x, giving you x squared. Then x multiplied by 4, that gives you the 4x. Then take the 12, move it over. That's what says now minus 12. And now you're looking at a trinomial that you will need to factor. Double parentheses, factor the trinomial, and then solve. So that means these parentheses, you have to solve the parentheses. That really is as simple as just do the opposite. I see x plus 6, so the answer is a minus 6. I see x minus 2, so the answer is a positive 2. Here's your solutions. Negative 6, positive 2. Check it. Will it work? Does it work with both of them? So you plug in a negative 6 for x, both spots. Work it out. Yes, it is true. Then take a positive 2, plug that in place for both of the x's, work it out, and yes, it is true. So the reason why we are checking our answers here is because you may actually have one of these answers not work, meaning it could be an extraneous solution, but then the other answer is true and it does work. So for those of you guys listening to these notes really carefully, that's important because you may have problems where you clearly get two answers, but when you check both answers, one of them doesn't work. meaning when you test it out, you plug it into one of those equations, you don't get an answer where it's like that number equals the same number, meaning it's extraneous, meaning it doesn't work. So don't include it in your final answer. All right, that's cross multiplication. Fraction equals fraction. Cross multiply. And when you have an expression, it's like you're distributing into the expression. All right, what if we have a denominator, an added piece, and these denominators don't match up? And what I mean by an added piece is, notice we have a fraction, then plus, then another fraction, then our equal sign, and a third fraction. So when you're looking at three fractions, you cannot simply cross multiply. That does not work. So step one is finding that common denominator, that lowest common denominator, all right, the LCD. So 5 cannot magically become x minus 2, nor can x minus 2 become 5. So just show the two of them next to each other. That's what we're doing right here. Show the two of them next to each other. That's our common denominator. Everything in this expression will be multiplied by our common denominator. This is the common denominator being multiplied 3 times because we have 3 fractions. And the key reason why you were doing this is to cross out those denominators. In other words, you're going to be eliminating fractions. You're just going to now have regular polynomial expressions. No longer will they be fractions. That's a good thing. We want that. That's going to help us, all right? Students are not fans of fractions. They'd much rather just have a regular looking number. So x minus 2 and x minus 2 will cross out. 5 times 2, that's what gives us this 10. Again, look at that. X minus 2, x minus 2. 5 times 2, make 10. 5 will cross out with 5. X minus 2 times 1 is x minus 2. And then there's another x minus 2 over here. X minus 2. 5 times x makes 5x. 5x plus x makes 6x. Then add 2, add 2. They don't show that step, but 6x equals 12. Divide both sides by 6. 12 over 6 really equals 2. All right, so I'm going to show you guys 2 example problems, one with cross multiplication, one where you have to find common denominators, multiply, and cross stuff out. So let's do these 2 example problems. All right, so follow with me here. First one, we have a fraction, equal sign, fraction. It meets the parameters for cross multiplication. So we will cross multiply here. 2 times 7 is 14. We will cross multiply here, but I want you to think of it as x times 5 and x times x. And don't forget your equal sign. That equal sign has to be there. So x times x is x squared, and x times 5 makes a positive 5x. Take the 14 and move it to the other side. Now creating x squared plus 5x minus 14, because we moved it across the equal sign. Now we have a trinomial that can be factored. X squared breaks down into x with an x, plus sign, minus sign, in that order. Plus sign, minus sign, that's what works out in the parentheses. Factors of 14 that can create 5, 7, and 2. Notice we need a positive 5. So that means we're going to have a positive 7 minus 2. 7 minus 2 will equal a positive 5. But we're not done, because we have to solve this. So do opposites. If this says x plus 7, the answer there is a minus 7. This says x minus 2. The answer is a positive 2. Now, I'm going to circle that, but let's take a look at the original problem. If we plug this in, will it work out? Here's the ultimate trick. If you plug in one of these values, negative 7 and 2, we're plugging them in, of course, for x. When you plug them in, do you ever create a 0 in a denominator? Well, that 7 won't ever be a 0. It's a 7. If I plug negative 7 right in there for x, negative 7 plus 5 is a negative 2. So that does not make a 0. So that one works out. Plug in a 2 right here. 2 plus 5 is 7. So that doesn't create a 0. So that means that both of these are actual solutions. One of them is not extraneous. Both are good. Both are actual solutions. So that one's done. Okay. Now let's take a look at example problem number 2 here. Let's give ourselves a little bit more space. Maybe we can move this down just a bit. Okay. All right. So what's our common denominator? That's step 1, because we know we can't cross multiply. We have 3 fractions. Doesn't fit the parameters for cross multiplication. I see x plus 4. I see 3. 3 cannot magically become x plus 4. X plus 4 can't magically become 3. So that just means my common denominator is them together. So the common denominator is 3 parentheses x plus 4 right next to each other. Okay? So if that is the case, then that means every single one of these fractions is going to be multiplied by this. All of them. And the reason why we're doing that is because this will cross out our denominators. This will start to simplify things and create a normal looking polynomial. All right, so let's cross some stuff out. X plus 4. X plus 4. I have a negative 12 times 3. That's going to make a negative 36. All right, 3 crosses out with 3. X plus 4 times 1 is simply x plus 4. That's nice. The x plus 4, the x plus 4, they cross out. 3 times x, it's going to make 3x. So here's all of the pieces that I have left. I have a 3x plus x plus 4 equals 36. 3x plus x makes 4x plus 4 equals a negative 36. Now, let's start to simplify this here. We don't have any squared, so we're not factoring. We're just using straightforward algebra, solving for x. Minus 4, minus 4. All right, so let's move that over there. 4x equals negative 40, and x equals a negative 10. Okay, that's how we do it. Let's zoom out just a little bit so you can see it all right there. So you first find the common denominator. In most cases, guys, it's just what are the 2 denominators that are different? Put them next to each other. Multiply every fraction by that and just watch those denominators cross out. Multiply, simplify, solve. All right, so we'll zoom out. There are the 2 example problems for section 5 here. And like I said, this is it for chapter 11. All right, this covers the last section. So there's your example problems right there. There's your notes right there. And that's it. All right, guys, bring your questions to class. Bring your effort into class. I will see you in the next one.